Good morning. This is Inorganic Chemistry 2 course for second year students of College of Science, Sudan University of Science and Technology. It is for the second year chemistry and second year scientific lab chemistry. The first unit of this course is about hydrogen. Hydrogen, as you know, is the first element in the periodic table. It is the first element above the elements of group 1. It consists the first period with helium in the far right part of the periodic table. Hydrogen is a reactive element when compared with helium, which is an inert element or a noble gas. The hydrogen electronic structure is the most simple one in the periodic table as 1s1, but the chemistry of hydrogen is not the most simple one in the periodic table unless or if it is not the most complicated chemistry compared to any other element. Hydrogen is not found as a free atom. It is always found as H2, as a diatomic molecule, where helium is a free atom, He, just. Hydrogen may lose the first or the only one, you can say, electron in its outermost shell to become hydrogen plus or a proton. The positively charged hydrogen is of high tendency to form bonds or covalent bonds with other atoms, for example, hydrogen or carbon, and so on. Hydrogen is sometimes similar to halogens because it can accept an electron to become a negatively charged ion, H-. Hydrogen atoms may attain stability in 3 different ways: by forming covalent bonds, by losing the single electron, or by gaining electron to form hydride ion, H- on reacting with alkali metals and some alkaline earth metals. These are the examples. For example, hydrogen can form covalent compounds with oxygen, with carbon or can lose electron, for example, to form hydronium ion H3O plus or ammonium ion NH4 plus. It sometimes form coordination bonds. Abundance of hydrogen. Hydrogen is suggested to be the most available element in the universe. It represents about 92% of the whole atoms of the element in the universe, followed by helium, which is represent about 7% compared with 1% for the all other elements in the universe. Because hydrogen is very light, its amount in the earth crust is very small. It is the 10th abundant element in the earth crust. As you know, the most available 10 elements are oxygen, silicon, aluminum, iron, calcium, magnesium, sodium, potassium, titanium, and hydrogen. Hydrogen occurs in large quantity or quantities in water bodies, such as rivers, lakes, seas, and oceans. Its compounds are many in living matters. If you are speaking about animals, plants, fuels, natural gas, coal, and organic compounds, as well as the different types of foods, carbohydrates, fats, lipids, and so on. Because hydrogen is very light, it is not easy to obtain hydrogen from the atmospheric mixture of gases, such as the case for hydrogen, nitrogen, and oxygen. You can obtain oxygen or nitrogen from the atmospheric gases or from the atmosphere, but hydrogen amounts is very low. So if we need to use hydrogen, we require to prepare it in procedures that give adequate amount for hydrogen. Hydrogen can be obtained by the reaction of hot carbon with steam or water vapor at high temperature to obtain carbon monoxide and hydrogen, and this is at once known as water gas, and in the former times it is used as a fuel. The combustion of hydrogen in oxygen atmosphere will give carbon dioxide and water. It is difficult to obtain pure hydrogen from water gas mixture. Therefore, carbon monoxide can be liquefied under pressure at low temperature to separate it from hydrogen. The gas mixture, therefore, can be treated with excess of steam and cooled to about 400 centigrade and passed via iron oxide to obtain hydrogen and carbon dioxide. Carbon dioxide is a soluble gas in water, so if we pass the mixture in water body, carbon monoxide will be dissolved and the hydrogen will pass. Since it is very insoluble, you can say that, or sparingly soluble in water. Hydrogen also can be produced in large amounts, for example, for industrial processes or purposes such as ammonia production or carbon or hydrogen chloride, or for hardening of oils. High light hydrocarbons such as methane can be mixed with steam and pass over nickel catalyst at high temperature. Here also you can observe that we also obtain the water gas mixture, carbon monoxide and hydrogen. The light gases, when ignited in excess steam, will give carbon dioxide and hydrogen, and again we can separate carbon dioxide from hydrogen by passing the mixture through a water body or amount of water. Any carbon monoxide in the mixture will be converted to carbon dioxide, which is finally absorbed in potassium carbonate solution to obtain potassium hydrogen carbonate as one of the most soluble compounds. The third procedure of producing hydrogen can be described as electrolysis of pure water. Very pure hydrogen can be produced by electrolysis of water or sodium hydroxide or potassium hydroxide in solution. By electrolysis you obtain oxygen and hydrogen, and with electrolysis of hydroxide ions we obtain water and oxygen. Large amounts of pure hydrogen can be obtained from industrial production of sodium hydroxide. Here it is a byproduct, as one of the products, as well as chlorine. So if we used electrolysis, or we electrolyze sodium chloride solution, saturated of course, we will obtain mainly sodium hydroxide, and the two gases, chlorine and hydrogen, will be obtained as byproduct. The fifth procedure for producing hydrogen is preparation of hydrogen in the lab, and this can be carried by using some metals and dilute acids, dilute sulfuric acid, dilute hydrochloric acid, or any dilute acid. The most suitable element for producing hydrogen in the lab is zinc, which easily can evolve hydrogen when treated with dilute sulfuric acid. The sixth procedure or method is by reacting some alkalis or alkali metals with by reacting aluminium with alkaline solutions. Aluminium can react with sodium hydroxide solution to produce hydrogen, and this reaction can take place with other amphoteric elements such as beryllium. So the reaction of aluminium with sodium hydroxide or potassium hydroxide can be considered as one of the procedures that can be carried in the lab easily. Hydrogen can be obtained as it takes place in industrial processes by the reaction of salt-like hydrides or the hydrides of the most electropositive elements such as lithium hydride or calcium hydride, which give hydrogen gas and give the hydroxide of the element, which will be aqueous, and it is easy to separate a gas from aqueous solution. Hydrogen can also be produced from incomplete oxidation of hydrocarbons. As we know, any organic compound, if completely ignited, will produce carbon dioxide and water, but in the presence of less amount of oxygen, we can obtain also the water gas, carbon monoxide and hydrogen. Reaction of water with high electropositive metals, and this is normally the elements of group 1 and some elements of group 2. This reaction is very easy and can take place very quickly in a violent way, so that any element, sodium, potassium, cesium, rubidium can produce hydrogen with water, but this reaction is sometimes explosive, and therefore, for safety measurements, we do not or we do not suggest it to be carried in the lab. But the molecular hydrogen H2 is the lightest gas known, because the other gases are all most heavy. It is not like carbon dioxide, for example, which is very heavy. So we always found hydrogen in the upper layers of the atmosphere. Hydrogen gas is colorless, odorless, and almost insoluble in water, and it is also insoluble in many other solvents. The hydrogen-hydrogen covalent bond is a very strong bond. It requires a great amount of energy, such as 435.9 kilojoule per mole, to be broken. So we need sometimes drastic conditions or catalyst, for example, high temperature or catalyst, to make hydrogen ready for reacting. Many reactions are either slow or require high temperature or catalyst, as we said. The catalyst combines with hydrogen or any other component at first, either to break the bonds or make the bonds very weak to be ready for breaking, and hence we can lower the activation energy. Hydrogen has so many uses in our daily life, such as manufacture of ammonia. Ammonia is mainly produced from the reaction between nitrogen and hydrogen. Also, hydrogen is used to hydrogenate some oils or to saturate some compounds with double bonds or triple bonds, where nickel, palladium, or platinum can be used as catalyst to add hydrogen to the double or triple bonds, and this is what is known as sometimes hardening of oils. It is also used in manufacture of methanol by reducing carbon or the reaction of hydrogen with carbon monoxide over copper zinc catalyst at temperature about 300 centigrade. reaction of hydrogen, we said that there is no free hydrogen atom in the nature. Hydrogen atom as just a single H or single hydrogen atom is not available in the air crust, in the atmosphere. It can be only available in some drastic conditions, as the case of the surface of the sun or the high temperature stars, and sometimes in the earthquakes and tectonic conditions of the earth. Hydrogen bears in air or excess oxygen to form water and liberate large amount of energy. This reaction cannot take place very easy. It takes place also in high temperatures. With halogens, hydrogen reacts violently with fluorine, even at low temperature, to form hydrogen fluoride. It is lessly react with chlorine in the dark, but the reaction can be fastened under photocatalysis to produce hydrogen chloride. Large quantities of hydrogen are consumed in the above. Ammonia and hydrogenation production reactions. You can see here the reaction already mentioned above of nitrogen and hydrogen, and the saturation of double bonds of organic compounds also with hydrogen, as well as the production of methanol, as we said before. Therefore, we can say that the molecule H2 is very stable and only dissociated at very high temperature or the presence of catalyst. Hydrogen, therefore, is suggested to be very good source of clean energy, since it produces only water when it is ignited or in the combustion process. But the problem is a very high temperature that results at the end of this reaction. هكذا نتوقف هنا, or we are going to stop here to start at another time. Good luck.